So good afternoon, everyone. We're going to get started. My name is Adrian Percy. I'm the Executive Director of the Plant Sciences Initiative. You are in the Plant Sciences building, and I'm really, really excited to welcome you here. I see a lot of people I don't know, and that is probably the most exciting thing. I know that's a bit of a strange thing to say, but one of the things that we want to achieve through this initiative is to bring groups together that perhaps don't always get to be in the same room. And so when I'm in a room where I see some friends and some industry partners, that's great. But when there are also some new people that can become potentially future collaborators, that's even more exciting. So we've just opened, as some of you who are on the Ag Research Foundation board know, this is actually our first day or 2 days of events. So excuse it, not everything goes completely perfect. But the main thing is that we've got a good group today to discuss One Health. This is something that's been championed from a few areas, and thank you, Deborah, for putting everything together. But the only thing I really want to say is welcome to the building. This is a public building. You are welcome to discover it. There are the front part of the building is open. You can discover some of the learning areas, see some of the meeting areas that we have. If you want a tour of the laboratories or the greenhouses at some point, just reach out to me and we'll do that. There's a lot of people who are curious to see what we have here, and we're kind of proud to show it off to you. So that will be no problem whatsoever. But with that, I wanted to introduce the Associate Dean for Research for the College of Ag and Life Sciences, Dr. Stephen Lommel. Please, Steve.
Thank you and welcome. Welcome everybody who's online. Can't see their faces, but I guess they can see me. I understand we have an international audience online. That's fantastic. I'm excited to see everybody here and to know that there's a lot of folks who are here virtually as well. Emerging research showcase events were developed as a way to introduce our external stakeholders to new emerging research projects here at NC State University and to frankly just link up, to find out what we're doing and to get feedback on what we're doing and look for possible interactions. Deborah has been sort of championing these in our college anyway. We've had a number of these in the past. This is our first one on One Health. Deborah does a lot of work working with our colleagues, our research colleagues, in identifying stakeholders and corporate folks and others who would be interested in this subject matter. And you guys are all here today because of that. The One Health concept, also known as One Medicine, is not new. However, it has gained worldwide acceptance in the 21st century as it becomes evident that human health is interconnected with the health of animals, plants, and our shared environment. The U.S. Center for Disease Controls and Prevention defines, and this is quite a definition actually, but let me roll through this, One Health as a collaborative, multi-sectorial, and transdisciplinary approach working at the local, regional, optimal health outcomes, recognizing the interconnection between people, animals, plants, and the shared environment. We all have that? I'll test on that later, but it's basically everything. It demands and fosters collaborative efforts between professionals in animal health, human health, plant health, and the environment to prevent pandemics and enhance public health and security. Proper implementation of the One Health concept will save millions of lives and billions of dollars in healthcare costs. While the linkages between agriculture and One Health are vast, NC State's disciplinary and interdisciplinary strengths, including infectious disease, both plant and animal, and food safety and security, create specific opportunities for us to impact this sector at the intersection of agriculture and human health. Today, Dr. Sid Thacker, Director of our Global Health at NC State, will lay out the vision of translating our educational research and professional development activities at the university into a sustainable employment in competitive fields as part of proposed GH Global Health Academy. Some of our external stakeholders and 5 faculty from across the college will help lay out the challenge and some solutions as they relate to NC State University's position as a leader in One Health, specifically in the area of infectious disease and food security. We are looking forward to identifying projects that we can implement together to solve the One Health challenges that face agricultural and life sciences. Today, in our opportunity to dig deeper and to begin with the process of identifying collaborative research projects, Deborah Thompson, our host, and Dinah Schuster, also our host back there, will be your guides in this event today. So with that welcome, I'll ask for Mike Elder to come up. Is that right? Oh, Dinah, I'm sorry. Sorry. Welcome, everybody, and thank you.
Thank you. Good afternoon. As Dr. Percy said, this is our second day in this beautiful new space, the Plant Sciences building. And in my role today, I'm Dinah Schuster, and I serve as the Senior Director of Development for the Plant Sciences Initiative. What that means is I'm the fundraiser. I'm accompanied by my colleague, Erin Meyer, also at the back of the room. And I think what makes this topic today really interesting for us is that it's cross collaboration, and that's something in the PSI that we're really excited about, is looking for funding opportunities to support all kinds of research and all kinds of efforts by our faculty and our scientists. So the way you do that is we are putting together different plans of kinds of support that we want. I work closely with Deborah's office. I know the invitation came from Deborah, but many of you I may know because we're looking for philanthropic support. So as the PSI becomes further developed with a lot of people working on it, we're going to be asking a lot of our corporate partners and individuals to help support that effort. So I, along with Erin and my other colleagues, are here to help ask those questions and answer the questions you may have. So thanks for being here today. And Deborah, I'll turn it over to you.
Thanks, Dinah. You may have noticed Dinah and I are giants among women. There we go. So yes, I am on tippy toes. That's scary. So welcome everybody to those of you who came in person and to those of you that are online. Great to have you here. We are, my name is Deborah Thompson. My role is analogous to, but not the same as Dinah and Erin's roles. My job is to make sure that we connect scientifically. And so this event is designed to get you excited about some scientific opportunities here at NC State that exist in collaboration with our industry partners in the region and globally. I get to do some of the logistics. So please, if you're online, or you're already muted because you're on the webinar. So that's easy part. Again, if you're online, there's the opportunity to ask questions through chat and through the Q&A function. Anthony the Marvelous will moderate the Q&A in the chat. And of course, with the people in the room as well. Do not be shy if you're online. Go ahead and ask those questions. With that, I would like to turn it over to Sid Thacker because Sid is going to give us the vision for the future of One Health through the Global Health Academy at North Carolina State University. Sid.
Do I use just to move slides? Well, in the meantime, thank you, Deborah. Dr. Lommel, Dr. Percy, great to be here. Take him on his offer to walk around the building. I had 30 minutes of lag time. I went all the way to the 4th floor, amazing greenhouse. I don't think I've ever seen such a bright greenhouse ever. And David was there with me. And the sun's not out. Amazing infrastructure. Thank you again for the opportunity here to come and talk about this proposed Global One Health Academy at NC State. So, you know, as you see, NC State has released its 2030 Wolfpack Pride strategy goals. There's 7 goals. And one of the major focus of the next strategic plan is to really break silos and create interdisciplinary programs. Some of you may know that Provost Office is currently interviewing candidates for a senior vice provost for interdisciplinary programs. So it's a really solid effort from the leadership to really break silos. As a result of that, two academies have already been announced at NC, are already set up. One is on data science and genetics and genomics. So I got 10 minutes. I'm just gonna take you through the thought process behind, how we have reached this stage and what we have lined up next as we move forward. So I'm gonna talk all about what these academies are. I think that's the first question I get asked. I said, what's an academy? I'm gonna just talk a little bit about what it is. I'm gonna just talk a little bit about the One Health model. Had a great discussion this morning with the CAL's Research Foundation Board about what One Health is and how actually I think we are all actually working in the One Health space anyways. I'm going to talk a little bit about why global health in North Carolina. It's a massive in a global health space with more than 220 organizations working in this area in the field of global health. And then I'm going to share us, some few slides about the vision that we have for this proposed Global Health Academy. So what's an academy? Real quick definition is these academies have to span all the 10 colleges that exist at NC State. So these academies are based in the provost office. They're not based in a college or a department. And again, the idea is to seamless integration across different programs. And of course, as a land grant university, it has to meet the mission of the university, which is research, education, and engagement. The strong focus on student education over here, and I'll share you like what the Data Sciences Academy is doing and what the Genetics and Genomics Academy are doing. But the keyword over here, as I've highlighted in red, is to really, facilitate integration and break silos across different programs that exist. And so these two academies that are already existing and the proposed academies, you can look, they're very interdisciplinary in nature, big picture focus, and the idea is to really, unite the different aspects of NC State in research, education, and of course, engagement. So just a quick slide about the two academies that already exist. The Data Science Academy, Dr. Rachel Levy leads it, and you can see their tagline is data science is for everyone. Okay, so they want every student at NC State to have some level of experience with data science. And then you can clearly see the trends where we are moving forward. It's very genomics and data science focused. And, so they want every student to have some level of, experience working in data science. So their focus is very much on education right now. But of course, research is a very key part of it. And you can see they're doing consulting, research ideation, career fairs, extension focus, industry partners. And Dr. Levy has been here for just around a year, I believe. And then the Genetics and Genomics Academy is led by Dr. Fred Gould. And this is coming out of existing, training program that they had for many years. And they are actually leveraging collaborations across all life sciences at NC State, focused, of course, on genetic and genomic underpinnings of life on Earth. So, they already had a training grant. And so this is next step for this particular program to really take the shape of an academy. So Dr. Lommel talked about One Health, the definition, what it means for CDC. My definition of One Health is very simple. It's health and health equity for everyone, including human, animals, and the environment that we share with them. You look at, explaining One Health to people has become easy for me ever since the pandemic has happened. It's very clear to say where it came from, animals and bats, and then we are finding it in wastewater, environmental reservoirs, and of course, the end result being humans. And the idea behind is right now we are focused on preventing more deaths from happening. As I mentioned earlier, WHO is saying that close to 16 million people have died because of this pandemic. More than twice or thrice the number of the Spanish flu. And then the idea is we work together, bring different disciplines together to really solve problems that are global, that are big idea problems that need people from different expertise to really come together. And so this proposed Global Health Academy at NC State is going to be focused on the One Health model. A lot of thought process also, as I will share with you eventually, is what's unique to NC State, okay, which is different from the existing global health programs in this area. There are big programs in Chapel Hill and Duke and RTI. Just creating another global health program is not going to get it done. We have to stick to what our strengths are, and I will share with you, what things that we are doing. So why global health? Even North Carolina is really big in global health. So this was a 2017 report that came out of the Triangle Global Health Consortium, RTI, NC State was a part of it. And you can clearly see some numbers over here. More than 220 organizations are involved in the global health sector in North Carolina. It attracts around 1.2 billion in annual research funding, job opportunities, adds a lot of value to what we do in this area. This is 2017 report. We are now working on our 2022, this year's report. And I bet this 1.2 billion annual research funding is probably double or if not more than that. So it's really, really, I tell people, if you can't work on global health in the Triangle area, then you really cannot do it anywhere. And especially in the One Health focus, you got a big College of Veterinary Medicine, you got a big ag school over here, got a College of Engineering, got med schools. So it's really a great place to really do, collaborative work. I think that's why we are all here. So the state of North Carolina Blueprint for Global Engagement 2020 was actually released last year in 2021. And this is a document that involves the UNC system, Go Global North Carolina, and the North Carolina Coalition for Global Competitiveness. And their document, I'm just highlighting the key features over here. It's what North Carolina needs. So this is at the state level. It's people who are well-educated, resilient, adaptable, and globally connected. Okay, so the key word is globally connected. We need a strategy that is focused, intentional, and collaborative, and an action that suggests promotes global opportunities inside and outside North Carolina. The committee's key recommendations are align statewide resources, efforts, and interest by leveraging the coalition as a clearinghouse for global engagement, find the champions in North Carolina, and I think NC State should be, as a leading land-grant university, should be that champion. And I will share with you what the vision we have for this proposed Global Health Academy at NC State, and it's going to be North Carolina first. And of course, we have to change the narrative, be more open to ideas, be more open to collaborations. And one thing that I'll mention over here, find the champions in North Carolina. If you look at the original document, it's in blue. And I was suggested to make it red if you want to convince the leadership in North Carolina State University, and I changed it to red. So what is this proposed Global Health Academy's think and do priorities? Vision is to lead the global health field in One Health through impactful and sustainable partnerships at North Carolina and beyond. Strive to be the local global health champion. We're going to start at North Carolina. As I tell people, you don't have to get onto a plane and travel abroad to do global health work. You can do global health right in North Carolina. There's amazing amount of work that needs to be done. So we start at home. As a land-grant university, I think that is really our mandate. Start with North Carolina, and then extend outwards. Be the leader in One Health. So we are one of the 17 organizations across the world that has a WHO, World Health Organization, designation as a collaborating center on One Health. I think it's very prestigious that WHO recognizes us in that capacity. We need to leverage it. We need to expand it further. I told you about data sciences. Their tagline is data science is for everyone. For the proposed Global Health Academy, it's really going to be, train the next generation global health leaders. So there's going to be massive focus on student education. And I will show you some data as to how strong an interest is at NC State for our undergraduate students to really, get more involved in global health focus courses. And then, of course, you got to address the grand challenges. Big problems need bigger teams, bigger solutions, bold ideas, and that's what we are envisioning in this proposed academy. So, what is this academy framework going to look like? I hope you appreciate this slide. It's a lot of effort that went into the thought process, and not just mine, but many of my colleagues also. So, really, the key word is interdisciplinary. Okay, we really want to, create an ecosystem working with already, amazing programs that already exist. PSI being one of them. We talked about food security, nutrition, and PSI has got to play a very important role in this. And the idea is really to make connections, but then let the individual, groups really, reap the benefits of these partnerships. That's the whole idea. So we're going to bring in NCSU internal resources, strengthen our engagement with partners, create new strategic partnerships. Okay, we want to create that ecosystem based on some pillars, which is for industry, government, universities, local, national, global community, to really focus using an interdisciplinary approach, focused on not just education, research, engagement, but also workforce development. And again, as I said, we really want to focus on creating tomorrow's global health leaders at NC State, North Carolina, and beyond. So we have created a global health leadership, and the idea, as I mentioned very early on, is these academies are based in the provost office with the idea to break down silos and the idea that these programs are across all the 10 colleges that exist. So been very cognizant of this, trying to bring in leadership and leaders who are champions in their respective fields. And we have identified 3 research thematic areas. You can see driving food and water solutions, combating infectious diseases, and addressing climate change and health disparities. So many of you may see Rob Dunn under combating infectious diseases. I'm so glad that I involved Rob very early on in this discussion. He's the interim senior vice provost for interdisciplinary programs. So I think it's great timing. Dr. Jean Ristino is sitting over there, is our leader in food solutions. We all know her, Francis, from the College of Engineering. Dr. Catherine Hoyo is going to be leading our efforts in climate change and health disparities, and Dr. Selin Pasalar of College of Design works on built environment. We have a very strong focus on our education aspect. Undergraduate, graduate not at this level because we don't have a graduate program. And I'll show you why we need to have a graduate program in global health. And then we'll work with the Shelton Leadership Center for providing leadership opportunities to our amazing students. And of course, engagement is a key aspect. And Blair Kelly and Tom White are going to be responsible for leading that effort. So just to give an example of what we're going to do is these 3 thematic areas that we have identified through multiple discussions and workshops and plannings. They're going to work with each other. What we don't really want to do is create 3 new silos. That's not the idea. You can see they all work very well with each other. They will have multiple sub-themes, which are unique to NC State. And that's the key thing. We have to stick to our strengths. One of the examples I gave is when I had my earlier discussion with Dr. Francis Del Reyes on water solutions. And I said, well, UNC has a big Friday Water Institute. And his response was, they work on policy, we are working on engineering solutions. And I like that. You got to stick with your strength. What are you bringing to the table? And so these thematic areas are very unique to us. And of course, they are our strengths. And of course, big ideas, student success, want to be globally engaged, want to address, UN sustainability goals, the 2030 goals, that 17 goals that we have, are still a lot of work to be done, but NC State has very unique strengths to address some of them. Our the education program is focused on undergraduate. We started with the global health minor for our undergraduate students in fall of 2019 with 20 students. We are already at 87 students. So we have already seen a 4-fold increase in the number of undergraduate students who want to take global health minor. We have actually refused more than 20 students because we are at capacity. And then these students go to graduate programs in other universities. And one of the reasons for that is NC State does not have a graduate program in global health. And I think we have to have one. So definitely we'll have plans to establish one. We have certificate programs. Right now we have one in the College of Veterinary Medicine. Then we'll extend these to other students, the opportunities throughout the university. And of course, I already mentioned about the Shelton Leadership Center. So this Global Health Academy focused on research, education, engagement. The idea is to go for big grants. NC State should be applying for 20, 30, $40 million USAID grants. I don't think so. When I wrote a Fogarty grant to train 10 graduate students from Senegal, and I went across the university asking who has done that before, I found that NC State has never, ever applied for a Fogarty training grant ever. And I think we should. I think we have everything over here to really go for those big grants. Global engagement, global health leaders, consortium, global hubs. We don't have to make brick and mortar building like the Prague Center in every part of the world, but we can establish global health hubs, NC State hubs across different parts of the world. We have an Office of Global Engagement that's engaged in so many different countries. I don't see any reason why we can't do that. I think we need to do it. Of course, entrepreneurship, hopefully global startups, a lot of amazing things that can be done. And here's the key thing. We are all doing this work in this massive university, but classic to to the large universities, a lot of the work is done in silos. I think this proposed academy has a strong potential to bring people together. And my last slide really is what is this proposed academy going to do? It's really going to be an interdisciplinary program that will cut across disciplines, colleges, and departments, and really produce, help train the future generation of global health leaders by uniting departments, colleges, and partners. And you can replace global with data science, or with plant science, or with food animal. And I think the aim for these groups, these interdisciplinary initiatives, is the same: is to bring people together, to really work together, and to really come in as a force. And I think we can at NC State definitely do that in the international and global arena, starting with North Carolina first. Thank you so much.
Sid, thank you so much for setting the stage for us. I have two questions, actually, and they're very different. The first is, following COVID, I think we can all understand zoonotics and their place in One Health. But as I asked you earlier, what is the place for plants in One Health? And you mentioned it just now, what is the place for water in One Health? So that's question number one. And then question number two is, you had a slide where you spoke about the importance of partnerships with external stakeholders. And I wonder if you can dive into what that means for you and for the proposed One Health Academy.
Yes. So the first question really is, the role of plants. I'm not a plant expert, but I can tell you, when I look at it, I'm really looking at it from a food security, food nutrition point of view. I think there is tremendous amount of work that we can do. The PSI is a great example. I know it's just started, but I look at Twitter, I look at LinkedIn, all the amazing things that you guys are doing. So from my perspective, it's more coming from food security, nutrition. As I mentioned earlier, 10 billion people by 2050. Animal protein is important, but so are, what we can do in terms of ag and of course the plants. So I think I look at it from that perspective in terms of the impact that we can have. Stakeholders, very important role. I mean, you look at North Carolina, massive, food animal production, second largest pork producing state. I think it's number one in turkeys, ranked number 2 in poultry. It's to bring them on board with, things that we are doing. And I think the engagement part is so important in all of this. Then I think we also need to bring in stakeholders. When I look at an institution like the World Health Organization, bringing them on board and telling them what we are doing. And, these institutions like USAID, for example, they're not just going to give you money. They want to really see what you have been doing for an extended period of time before they really say, okay, the NC State is really doing things that we want to see. So let's invest some more funds in that. I always say, no federal money can match what a donor can do, with no strings attached. So, fundraising, really telling people why it is important, I think is the way to do it.
Can I just ask for a clarification? You mentioned a WHO recognition as a global health center. Was that not for NC State or for the region?
It's at the College of Veterinary Medicine. So okay. We are a World Health Organization collaborating center in antimicrobial resistance and One Health. It's one of 18 such centers. It took us maybe around 4 or 5 years to get that designation. And it's a very prestigious thing, in my opinion. So want to leverage it. Because, it caught your attention, and so it does make an impact. And so, long road towards getting something like that. But once you get it, you got to maintain it. But then you got to use it to do some other amazing things. So it's really a regional thing. Yeah.
You gave the definition of the CDC for One Health, and it says animals, humans, and the environment, and it doesn't mention plants. And consistently, plants are left out of the whole One Health dialogue. And I think that's a strength we have here at NC State, particularly in College of Ag and Plant Science Initiative. So why name this Global Health Academy? Why don't you name it the One Health Academy and put plants in the definition?
Yes. So thank you, Jean, for that comment. So yes, I know. and Jean and I've had this discussion in the past. So I think Jean, what's going to happen is when I had my meeting with the provost last week, he did ask me that question. And I think his question was more centered around, we are leaders in One Health. So why not include that in the academy? And also helps us to differentiate from some of our other institutions over here. So my feeling is will probably be called the Global One Health Academy. And we'll make sure that plants are an integral part of it. And not because Adrian is sitting over here, because I think it's important. I think it makes sense.
Are there other questions in the room? Yep.
Yes,
Hang on,
ma'am.
Nandini.
Sid, I think this is great. Global health or global One Health, I think both are wonderful. You talked about something about getting recognition internationally. And you also mentioned that there are global health, maybe not academies, but institutes and focus areas at the other universities and RTI. So would you see some sort of interaction with those, even because you are distinguishing NC State from the other universities? So maybe there is complementary activities that will take place.
Absolutely. I mean, we are not trying to set up a program that's going to be, ultra competitive. I think it's global health automatically means you're going to collaborate. But I think what the point I wanted to stress was when you go to the stables, you have to bring some unique strengths that are complementary, or they don't have it. And so when I look at NC State, I'm looking at, one of the top 3 College of Veterinary Medicine, a really top ranked College of Ag and Life Science. I'm looking at a massive and amazing College of Engineering, and in addition to other programs also. So really, to make a strong case, why, as I say, in this area, triangle area, to start a global health program is like playing Super Bowl wearing diapers. You're in a heavy program that exists for 40, 50 years. I was looking at the strategic plan for Duke Global Health Institute. When they did the fundraising 3-4 years ago, they generated $55 million. And I'm trying to negotiate for funds with the provost over here. So, I want to be strategic about how we do things, what are unique to us, but they have to be complementary because that's when, it excites our partners. Okay, we don't have that, but they got it. So, let's talk about it. And the other thing we have to do is, got to move away from some of these efforts where we are collaborators and co-PIs to really be lead PIs. And I think this is an effort that can hopefully, at least, I'm not saying we do it in many different areas, but it's in global health area, we have some very unique strengths over here. And people are already doing global health work. As I've did my homework, every college has a different name. International programs, global engagement, they have a different name. At the end of the day, they're all doing the same thing, but they're working in silos. I think this is really something, that's why I like this academic concept, because they are based in the provost office. They're not based in a college and department. It spreads across all the 10 colleges. And I tell people, you got a problem, go and talk to the provost.
See here. So I'm seeing your vision. I understand completely the urgent need of the One Health, right? So walk me through clearly understanding I would say, approach that you have in terms of bringing together the strength of this university. That means that are you thinking and you have research and you have education and you have stakeholder engagement, what kind of, are you going to identify, say, use-inspired basic research? So are you going in your academy to look after, say, what are the knowledge gap? Are you going more to look at what are the current missing application and then build the science towards their response? Is more about the education in the knowledge gap across the different One Health, or is more about the research, or is all of it? And so you're gonna touch on, similar to what we do in the PSI, you're gonna touch on what are the knowledge gap, the technology gap, and you're gonna build on that as a conduit and a pipeline to then apply for the need that are out there. So can you try to make me walk through your approach?
Yes. So, yeah, the great question. So I'll tell you the approach I took when I started thinking about it. So I lead the global health program at NC State, right? I lead it in the College of Veterinary Medicine, NC State, and I am I sit in the directors meeting in the Office of Global Engagement, and N of one, no staff, nothing. And so it got me really thinking, and as I interact with them, I've been here 15 years. So I have a decent understanding about, what people do and what are the strengths. I was associate director of Comparative Medicine Institute for 5 years. So, from a research perspective, it's like, why can't we do it? So I just went across, talked to all of my colleagues. Jean was one of the first persons I spoke with, interacted with, college leadership, deans, and then really had these workshops and meetings and made a case to the pros. Now, this is what the university faculty are looking for in terms of, you talk about interdisciplinarity. Well, here is a great idea that we want to do it. How are we going to move forward? I think a lot of direction needs to come from what we are looking for. But clearly it has to align with some of the big grand challenges that are existing over here, and food safety and nutrition security are one of the key ones, right? So what are the big challenges that we face, and what are the strengths we have over here, and what type of partners do we need? I strongly believe that these academies have to be sustainable at some level. And I think sustainability comes from big grants. And I think so research focus is going to be key. But that does not mean that the education program education is very important. I look at the stats, 87 students in global health minor representing 7 colleges. So the provost vision about, these education programs should be across all the 10 colleges. We are already, 75%, 80% already there, even before the program exists with no resources. And then I look at the stats, where are these students going? They're doing PhDs, masters in UNC and Duke. And I'm like, why can't we have them over here? Because we don't have a global health program for graduate students. So we want to do minors that don't exist other place, like one in citizen science, right? So create these minors. And then, once we have these minors with success, then you establish a graduate program in global health, which is challenging, as I heard. It takes 4 or 5 years to establish a new graduate program, but we are committed to it. We are committed to our students. And engagement, absolutely. I talked about the stakeholders, North Carolina, just food animal production is massive. So really start from there, engage with the community, colleges over here. So really starting from North Carolina and then expanding outside.
So there's a question online.
Yes.
We had an anonymous question. Do you reckon it would make sense to transfer the One Health approach to technicians as well, e.g. workers in the livestock farming industry, or any other vocational education and training programs? If yes, what do you think would be the best way to transfer such knowledge and topic?
So I think one of the ways that I think people will find attractive is through the certificate programs. Fancy State's definition of certificate program, I believe it's 13 credits or more to get a certificate. So create those specialized certificate program that they need. That's the best answer I can give at this stage. But definitely, we have that in mind. And I think the online or in-person certificate programs is one way to provide that additional expertise and certification that they need.
Please join me in thanking Sid.
Thank you so much.
Very
Aya.
interesting start. At this point, I'd like to turn it over to Mike Elder. Mike is one of our fiercest champions in the College of Ag and Life Sciences. And he's also a very fierce champion for One Health, as I think you're going to find out in a minute.
Thank you, Deborah. My name is Mike Elder. I'm an industry partner, and it is, I think that was a very nice way of calling me a squeaky wheel, because that's exactly what I have been for the last 2 years. And I think Deborah and I talk almost every week as our industry specialist liaison director. And probably I mention it every week that we need to talk about One Health. So, And this all started with the conversation with Sid about 4 years ago. So coming full circle. I think that it also started with me with the UN Sustainability Development Goals. Novozymes adopted those goals. We actually looked at what we could commit to and how we could focus on that. I challenged NC State, where are you in this picture? That was a lot of good conversation. Still don't have all the answers, but I think for me, that's the deliverable. And we have to stay focused on that and find a way to do that. One Health is definitely a solution or a set of solutions to help us get there. And I think a responsibility that the university has, as well as private citizens. There are no corners of the earth anymore. You can be anywhere quicker than an incubation time. That's pretty scary. That's where we are today. And that's not going to get any better. That's going to get worse. It's going to get faster and faster. Subsonic jets are coming. It's not going to take you 13 hours to fly to China. It's going to take you 4. So there are no corners left, right? And so that will have an impact on us as we go through One Health and what that means. And how are we going to be prepared for that? Because it is the world that will shift. And it's going to take a village to do this. Sid talked about silos. We've had a meeting earlier today to talk about silos. There's a lot of fantastic work going on at NC State. There's a lot more that could be done. There's a lot of silos that can be broken down. There's a lot of industry partners out there that would love to be a part of the solution. There's a lot of tools. There's a lot of technologies that are coming out there. It's not one technology. It's not CRISPR. It's not nano something. It's not big data. It's not genetic. It's going to take a lot of different things, a lot of disciplines. And that's really what the whole dream is. That's what Sid's trying to pull together. And that's where we think that the exciting part comes is how can we leverage that, how we can make it a better world for our children and our grandchildren as we go forward. So that was it. Squeaky wheel.
We've got a couple of sort of rapid fire presentations coming up, so let's hold questions until the end of that. It is my very great pleasure to introduce my friend and collaborator, Paula Barngrover. I met Paula when she led a group from Premex in Colombia, asking the question, is NC State the place that Premex needs to create a US site, excuse me. So together with my colleagues at the vet school, I think apparently we convinced them. They're here. They've been here for several years. And some of you have heard me speak about the partnership triangle. Paula has made sure that Premex and now Illuma meets the university on all 3 corners of the partnership triangle. They have immediately hired one of our grads to lead the local site. They have sponsored research in the college, and they are involved in philanthropy, the 3 points of the partnership triangle. So please join me in welcoming Paula.
Thank you. I'm Paula Van Grover. I'm definitely an industry partner with the university. We call ourselves an industry partner because we like not only to get advantage of what we can find here, but also contribute to what we can work with you. Because we live in collaboration, and this is what I want to share with you today. The One Health, the One Health initiative is one of the concepts that move us around the industry. And we want to share with you some beliefs that we have. We are in the most interesting 30 years for humankind. Alvaro Gonzalez Alorde is one of our advisors, and he helped us self-developing ourselves as executives. And by that, we also need to connect with purpose, and our purpose is nourishing wellness. And when we talk about these 30 years, we are really excited about living in it. We say in Illuma that if we would have the chance to choose a time in history, and an industry, we would have chosen exactly this time and in this industry, because we cannot find anything more relevant than feeding the humankind. And that's what we all do here. And I wanted to share that with you because that's what moves us forward. The One Health initiative is definitely what put together all the areas of knowledge that we work on. But at the end, we are all feeding human lives. And I do know all the risks and the challenges that we have, diseases and contamination and food safety and food security. But at the end, I want to share with you our excitement about the opportunities that we can find there. I don't want to talk about the enormous risk that we have about getting sick and we're going to get locked up again. And yes, we're going to be moving faster than incubation times. But I want to talk about the opportunities that we have in this interconnected world. Magic happens when different worlds work together. And we have seen it in our company. In our company, we have seen how different disciplines get together in a table. Physicians and veterinarians sit together and they find things that you never thought about. Animal nutritionists and human nutritionists sit in one table, and sometimes the human nutritionists don't like it, but the animal nutritionists know more than the human nutritionists about micronutrients and about microbes and about all that. And because of ethical issues, the animal science is able to get deeper than the human science. And we do believe in the interconnection. Within the company, when we put together those worlds, we get very clever solutions from our point of view, and that's how we feel that we're contributing to our purpose. So interdisciplinary efforts are definitely required, and I cannot think of a better place to do this. In North Carolina, and there where I was helping us through all the process. The reason why we're here, I think you all know, this is the only place of Earth where you can put together different science under the same geography. You have human nutrition, you have human health, you have animal nutrition, you have plants, you have soil, you have all these. And then when you see that the state itself as a government has a purpose of impacting human health through nutrition, is a pretty neat thing. So we have all the resources, and I am totally positive that the solutions are going to come from this ecosystem, and that's why we're here. And we cannot think of a better place where this is going to happen. In North Carolina, and specifically in North Carolina State University, where all these disciplines are under one roof, this is where it's going to happen.
Thank you, Paula. It's my pleasure to welcome AgBiome to the podium. Rebecca Kelly is here from AgBiome. Now, they're a marvelous company, fascinating and truly the brainchild of some of our serial entrepreneurs in the ecosystem. We can't call you guys a startup anymore. I think we have to say you're in the growth phase, but we're very glad to have you, and so glad that you agreed to come and talk to us. Rebecca.
Thank you. It's great to be back here. I haven't been on Centennial Campus since the early 2000s, and a lot has changed. Yes, so it's great to be here. I just want to start the talk. One of the questions that I've been thinking about since grad school is, what's more important, the system or the parts? And that's what I really think is unique about One Health. Like, you've got this complex system that's all working together, but there's parts in there that are really important to understand. And what are those levers to make an impact? So just thinking about human health and animal health, they all work together, right? And we talked about food security, and food security really is not only, providing nutritious food for people, but also what is the impact of being able to provide that food on the environment? And that impact on the environment can also then impact human health. So one of the big things is agriculture, right? That's how we address food security, but that agriculture itself, the practices and producing food also cause environmental impacts. So at AgBiome, we're really focused on agriculture. So that's what the talk's gonna be focused on and how we can work with NC State. So agriculture is resource intensive. It's a huge reliance on fossil fuels for the equipment, the machinery, and indirectly on producing the nitrogen and pesticides that need to go on the crops to protect them to keep those yields up. It also is, there needs to be a lot of land to grow the crops, right? The population is going to continue to increase. So providing that land or increasing the yields of the crops to be able to provide for food security. With that, you can get damage to the soil. So if you're cutting down the forest, you're degrading some of those soils, and also just the constant pressure of the pesticides and nutrients on the soils can also be damaging. And from that damage, you can pollute the water, and there's also a lot of water that needs to go into agriculture to grow our food. So all of those have huge impacts on the environment. So there's a lot of talk about how do we grow crops more sustainable, both for human health and also for the environment as well. So, the land is declining, there's more mouths to feed, those challenges are here. There's also growing resistance to the current products that are out there, the old products. There are new products coming onto the market, and how can we continue to find new products that are safer and better for the environment? Consumers want clean, healthy food, and the government is also, the regulators are seeking to reduce the chemical load that's going into the environment. So, one of the things is what AgBiome focuses on is finding solutions for this through microbes. And this is, one of the things we have partnered with NC State through the micro department to bring in some of that expertise. So we're looking at microbes to provide crop protection. Microbes have a lot that they can do, right? We know that they can fight some diseases. They also provide soil health. So can we use these to reduce some of the chemicals that are going out into the fields, use them for resistance management and also worker safety as well. And so, the earth microbes have been around forever. They've evolved with the ecosystems, with nature. So how can we learn from what nature's produce? So really understanding the fundamentals of what microbes can do, what the powers are. Microbes were once thought of as harmful to us, but now we understand how beneficial they can also be through the gut microbiome for soil health and everything else. So what can we learn from what nature's already doing? And so, one of the things also NC State where you can play a role, what I really loved is data science for everybody, because data science is key right now. We're focused on the microbes and the genetic diversity there, but you also have the plant genetics and human genetics as well. So really understanding more of that. So it's not only, this data science piece on top of all the sequencing that we can do, but also understanding what those characteristics do. So it's very multidisciplinary, and it takes everyone in order to understand the mechanisms that are happening at the cellular level or the gene level, and also how to pull that data together and look at big data as well to make those connections. So, really, we focus on microbes through this. We have one fungicide that's out on the market, one that's we're waiting for EPA approval. We also have we're looking at insect control genes. But one of the things that really we have through our micro collection, we have discovered novel CRISPR systems. And that was actually done in partnership with a graduate student at NC State that was then spun off into a human health company to deliver novel therapeutics. So that's, State's been a great resource for AgBiome to continue to grow and use, what you guys are doing here, from educating people to the fundamental research to the bigger research. So I think it's really exciting to see One Health and bring these partnerships together. It takes everyone. The second thing that we also did was an animal health project, and we also worked with NC State on that as well for the expertise that they have. So developing microbial replacements for the antibiotics that are being used. And through that, we also sponsored a student here, Lauren Anderson, as well. So It's really great that we're in RTP. It's great to have NC State right here that we can continue to work together. In order to solve these problems, it takes both a multidisciplinary approach and it takes all of us looking at it from different angles and bringing that knowledge together. So that's all I have. Thank you.
Thank you, Rebecca. At this point, we're going to go virtual. We're going to Washington, D.C. to hear from Tim Kurt. Tim is with the Foundation for Food and Ag Research. And Tim, I got you. There he is. Welcome, Tim.
Thanks, Deborah. My pleasure to be here. Thank you for the invitation. I'm going to share some slides with you. Bear with me for just a moment. And I apologize that I am unable to attend in person. I do appreciate the opportunity to present to you all virtually. Okay, so I assume everyone can see my screen. Please let me know, Deborah, if that's not the case. I'm happy to talk a little bit about One Health from a funding agency perspective. So I work with the Foundation for Food and Agriculture Research. I'm a scientific program director and I oversee our advanced animal systems area. We have a number of other program directors who work on plant sciences as well as soil and water management. And I think a lot of what we do actually fits the One Health description. And so just for those who are not familiar with the Foundation for Food and Agriculture Research, we're a 501c3 nonprofit that was created by Congress, actually as part of the 2014 Farm Bill, to build public-private partnerships to support innovative agriculture research. And to date, we have received $385 million from Congress to support this work. We've built partnerships with over 400 different organizations, both small and large, really across the agriculture sector and beyond, and a number of projects at North Carolina State for that matter. So as was stated by some of the previous speakers, the One Health concept is a collaborative, multi-sectoral and transdisciplinary approach that incorporates both people, animals, plants, and their shared environment. And this is a definition that's been created by the CDC, which I believe is widely accepted and used. And I think it's very all-encompassing. So this is the definition that I most frequently refer to when discussing One Health. But I do want to emphasize that One Health is not a topic. It's a way of thinking about problems. So it's a way of anything can almost anything can be addressed through One Health thinking. It is systems thinking. It's a way of looking at problems and considering the role of animals, humans, and the environment, and considering impacts on animals, humans, and the environment. And so if we keep that in mind, these multiple lenses, we can start to think about some of those big challenges that Dr. Thacker discussed early on in today's session and kind of put them into the context of how do they become a One Health issue, or how do we address them using the One Health concept. So here I've used an image which I think really is helpful in imagining how we could look at issues of sustainable development, for instance, and the impact on climate and biodiversity, the impact on livestock and on crop production, for instance, but also on human health. So one of the challenges that we talk about a lot is the need to produce sufficient, nutritious food for a growing global population as we approach the year 2050, while minimizing the impact on natural resources. And so I think a lot of what we're doing is aimed at that ultimate goal, that aspirational goal, but we often work in silos. And so being able to combine some of these different aspects into a single project, to me at least, is what really exemplifies the One Health approach. And I do think at the Foundation for Food and Agriculture Research, we have a lot of interest in supporting research that does cross these different areas. Of course, it does have to be relevant to agriculture, but we do a lot of work that crosses between the environment, water, soil, climate, and of course, livestock production, which is my area at FAR, and plant production. So as I mentioned, I think actually One Health approaches are especially useful in addressing wicked problems. These are our grand challenges. These are issues that are frequently never completely solved. They can take a long time to evaluate solutions, but it's critically important to evaluate the impact of those solutions from different angles. And that's where we really get at the One Health approach. They're often interconnected with other problems, and there are other trade-offs that need to be considered when addressing these types of issues. And of course, there's multiple stakeholders. And sometimes those stakeholders have conflicting opinions, conflicting agendas, and different needs. And so that, again, is where it's really challenging to address, and maybe even more important that we try to take these systems approaches to solving them. I wanted to throw out just a couple of examples. I think these are probably blatantly clear why these would be good topics, example topics for a One Health approach. So one of these would be the area of emerging infectious diseases or zoonotic diseases. These can include vector-borne diseases. So there's an image of a mosquito, but there are many tick-borne diseases out there. These can obviously impact animal health, both livestock and wildlife, human health, directly or through a species such as a livestock or wildlife animal. But then the range and spread of these vectors is often affected by environmental conditions, so deforestation, a land use change, or changing climatic conditions as well, where we see changes in the distribution of certain insect vectors for these diseases. So this is a really great one. It comes up very frequently. I'm sure many of you are already well aware of this one. Another area which I think is an excellent fit for One Health research is environmental sustainability, broadly speaking. So we use the terms adaptation and mitigation. So I think the previous speaker mentioned that livestock, for instance, can both contribute to climate change and to environmental impacts, but in some cases can actually help mitigate those impacts too, and crop production as well. So changing temperatures can impact our ability to produce plants. They sequester carbon, and the way that we graze livestock can also potentially sequester carbon and reduce the impact on the environment. But at the same time, some of these production practices do have a negative impact and can contribute to sustainable goals. All of this really feeds into human health and food production, of course, as well, which is the ultimate goal for agriculture. And then, of course, we need to be cognizant of the impacts on water, groundwater use, as well as potential nutrient management, manure management, and other issues that may come from downstream from fertilizer application and manure application. So I like to say it's a bit of a two-way street. Some of our practices impact the environment, but then our changing environment, of course, is impacting our production practices, these animals, and human health, of course, as well. So the interrelatedness of this is really, and the ability to incorporate the different perspectives is what makes it ideal topics for One Health approach. So I do want to mention briefly some funding opportunities at the foundation that I think are well suited to One Health research. Probably our first and foremost is the Seeding Solutions funding opportunity, which is open annually and will allow requests of up to $1 million per award. This is really the opportunity where we're looking for transformative research and big ideas that can cross multiple of our challenge areas. So things that might cross between soil health, crop production, as well as livestock production, and maybe even water, urban food systems, and health ag nexus, which is our other challenge area. This is really a good opportunity to submit those projects. Obviously, as I mentioned, they need to have an ag component, but that we are open to supporting broader projects that may be a little bit beyond agriculture. Our Rapid Outcomes for Agriculture research does support research on, for instance, pests and pathogens. So we do have a mechanism to do that. This one, I would say, is maybe not a perfect fit with One Health, because we are very applied in the outcomes that we're hoping to achieve through the program. But because it focuses on, for instance, tick-borne diseases and other pests and pathogens of plants and animals, I thought it was worth mentioning here. So this is a program that's open all year at any time. If there's an emerging infectious disease or a vector-borne disease or pest itself, this is one where you can contact me and we can discuss whether it might be a good fit for the program. And then lastly, the one that comes to mind is our FAR Vet Fellows program, which provides $10,000 per student to support research on grand challenges. That's actually how we originally conceptualized the program. And we've had students work internationally on issues similar to some of the ones that have been described earlier, whether they're looking at population change and movement, looking at climate change, looking at antimicrobial resistance and food security issues. This is really a great program for students to get some experience in these areas so that we're preparing veterinarians for these future challenges. And I know not everybody there is in the animal sciences. We do have a FAR Fellows program, excuse me, for non-veterinary students as well. I apologize I didn't put that information on the slide, but please do go to our website and check that out as well. That I think also provides for some really excellent training opportunities for students who are not in the veterinary sciences. So some example awards that we've made that fit the One Health perspective. We've got projects on, and this is mostly within my portfolio. That's a caveat I have to throw out there, but we've got projects on environmental and economic impacts of integrated livestock production. So how do you graze beef cattle on row crops and incorporate, for instance, a winter wheat rotation? What are the impacts on methane and nitrous oxide emissions? What are the impacts on the animal health? And then, of course, that's there are economic benefits, or at least there are economics that need to be considered for the producers, and both of these production practices are aimed at producing food for, obviously, for the human population. So this one fits that environmental research area. As far as climate goes, we've got projects looking at heat stress and trying to improve resilience or adaptation of livestock. This is obviously an issue for humans as well. We've got projects that are also looking at enteric methane mitigation, and we will have more coming up here in the coming weeks. We've got a fairly large project on soil and water impacts of dairy production and manure processing and application. So that's a big one where we look at soil, water, manure from those animals. And of course, dairy is well known as being very important for human nutrition as well. And then lastly, antimicrobial resistance, I think, is actually a really good area for One Health research because, of course, it can directly affect humans. It can directly affect animals. The way we use antimicrobials in both those populations is important to developing resistance. Perhaps lesser known, a number of antimicrobials are also used in plants. And so that's an issue for resistance. We do have a project where we have researchers who are actually going out to swine farms twice a year and sampling for a number of different pathogens, and these include food safety pathogens. So there is a human safety component to that work. We're also looking at the environment and whether antimicrobial resistance is an issue from the environment, and trying to better understand whether it's actually linked to antibiotic use on farm and or not, because in some cases we see antibiotic resistance is actually not related to the way that producers and veterinarians are treating their animals. So there are a lot of questions there that are important for human health, as we've heard from other speakers today. So in closing, I just want to reiterate that One Health is an important type of systems thinking. I think it's especially important as we're considering these grand challenges. And I'm really excited to hear that North Carolina State is launching this global One Health Academy. That's excellent news. And I think it's clear food and agriculture challenges in particular can benefit from a One Health approach. And there's a number of different ones that are that really fit into this topic, this wicked challenge description, from AMR to sustainable intensification and environmental impacts work as well. So thank you again for the opportunity to speak. My contact information is here, and I'm happy to talk with any of your faculty afterwards, if you feel free to reach out to me by email, and we can arrange a time to talk. So thanks so much.
Thank you, Tim. We're very grateful. And don't go away, because we're going to have questions from both the in-house audience, but also I saw at least one online. Also, Lauren is here from FAR. So if you have questions that you want to specifically ask her while we've got her in the room, that's an opportunity. It is a great pleasure to welcome Pam Marone. Pam is an NC State CALS grad and serial entrepreneur. And so we're very proud of her as a grad. And I think she's going to answer some of my questions about the role of plants in One Health, aren't you, Pam?
And also the role of entrepreneurship. I just happened also, thank you, Tim, for the presentation. I happen to be on the board of FFAR as well. I live in Davis, California, not far from where the leafy greens are grown on the Foggy Coast. And in the wintertime, when you get your bag salad mixes, we grow them. And it's remarkable that to this day, we still have so many foodborne pathogen outbreaks. And some years back, with little scientific data, the food companies that buy the growers' produce imposed draconian food safety measures on the farmers. And you could not have a deer hoof print in the field. You could not have a bird splat on your lettuce. I mean, it was scorched earth policy. And what happened after that, the farmers, destroying the biodiversity on the farms and the farmers having to incur all those extra costs. Of course, the food companies didn't pay for those extra safety measures, which turned out didn't work at all because the foodborne pathogen outbreaks continued unabated, regardless of the scorched earth. So obviously, they looked at the role of nearby animal production and the water from those productions, but and what's the role of crop inputs, the role of foodborne pathogens like E. coli actually being taken up into the spinach themselves. And so despite all of this work, we still have a murky picture of what's causing these continuous outbreaks. And interestingly, there's a whole industry that's grown up in indoor farms or controlled environment ag. And one of the biggest ones just had a recall. And they said it couldn't happen. I talked to the entrepreneurs that, no, we have clean houses. We're never going to get that. And they said that about getting pests and disease and plant pathogens in there too. But lo and behold, they find a way. So the role of entrepreneurship. So after, all this research being funded, they said, okay, we're going to do a call for startups to come and help solve these problems. So there's a Western Growers, the growers all banded together in an organization called Western Growers Association. And they have a Western Growers Center for Innovation and Technology, and put out an RFP for startups to come and help solve these food safety problems, because you need more innovation to be and felt that the fastest, most efficient way you could do it was through startups. And I agree with that. And in addition, they also have a post-harvest automation startup initiative because of the problems we have with getting labor. That's the number one problem besides water in California. And so automation is going big guns in California through that innovation as well. And I'm working with the Western Grower Center for Innovation to set up a biologicals initiative to vet biologicals on the farm faster, because California, in its excessive regulatory restriction environment, eliminates chemical pesticides before everybody else. And then the growers are left without alternatives. So they want faster vetting of the biological solutions than what the university can do. But you heard from Rebecca, I'm also a microbe person. So I spent my career in microbes. I've actually screened several, I don't know how many hundreds of thousands of microbes over the career of the 3 companies I've started. Actually did it at Monsanto right out of graduate school, screening microbes, over 150,000 microbes at Monsanto before they got into GMOs, or at the same time where they were doing GMOs, and really fell in love with microbes. And so started 3 companies in California. And the first one was actually a subsidiary of Novo Nordisk, now Novozymes. And started up a company screening microbes and screened over 50,000 microbes. Novo Nordisk at the time sold us to our largest competitor because we were way ahead of our time and said farmers were not ready to adopt these things, which is true. But that's changing now. But soil health is all the rage and right now. And I like the definition of soil health that talks about it as living ecosystem, because we don't even, as you heard from Rebecca, we don't know barely know what's happening in terms of the microbial world and its relation to plants and plant health. There's so many papers every single week trying to unravel what's happening. And it's very exciting time. And there's so many startups that are working on this area. So One Health has a huge role in food for health and soil health. They're all interconnected. There's just this week, and I see so many of these, Civil Eats puts out a very good newsletter, and they're really into regenerative agriculture. And they found that minimum tillage and an increase in mycorrhizae fungi that colonize plants provided an increase in important amino acids for human health, and gave better nutrition with these increased in amino acids. And so how the farmer is farming and the role of the microbes is really connected to nutrient density and the healthy food. And so a lot of regenerative farmers and other farmers who are changing their practices to enhance soil health are finding and measuring with real science a higher nutrient value of the food they produce. So that's a very exciting area for One Health. Now look at the financings of the investments into agriculture technology and food technology over time. Oh my goodness, look at 2021. We might be off in 2022 because the stock market's off a bit, but there's still an amazing number of startups being funded and the amounts of billions of dollars going into ag tech and food tech right now, and climate smart tech and climate smart ag. And so here's the breakdown of where it is. Now you can see e-grocer, which is the big blue one. So food delivery, that's exploded obviously, but there's a lot of money going into precision technology, robotics, ag biotech, novel farming systems, and so forth. So you have a very, very vibrant startup ecosystem here. And it would be great to see One Health just spinning out startup after startup to help solve some of these very big problems. So with that, I will end. Thank you.
So a ton of information, all really fast. What I'm going to do is I'm going to ask Pam and Rebecca, there she is, Paula and Sid to come back to the podium, please. I don't know if we can get Tim on the screen. That would be awesome. And we're going to pepper them with questions. So. I saw there was one online. We'll wait for Anthony to get Tim back up. But I'm going to actually start. And Tim, I hope you're listening. Each of you are, except for Sid, of course, each of you are external stakeholders. And so my question for you, and I've already had this one texted to me from a colleague, is why are each of you here in a conversation about One Health? Sid, you get a buy on this one. What is the potential interaction between industry, funding agencies, and academia when it relates to One Health?
I'm happy to. Is this on? This is on. Yeah. I'm happy to address that. So through my entrepreneurial career, I've always had collaborations with universities and always had students working and shadowing executives, shadowing in the labs, and lots of interns and externs, and hiring so many graduates of the local universities nearby, and funding research at various universities, and also licensing technologies from universities. And so there's you can't do it you can't do it all alone by yourself. You really need to tap into wherever the innovation is happening. And I'm agnostic as to where, to who has the technology. If it's something interesting, I'll license it, I'll collaborate and do so. So that's why I'm here. And NC State is just building a very great ecosystem, and I really appreciate everything it's doing here from the Plant Sciences Initiative. And so I'm sure there are going to be a lot of collaborations. My company, Marone Bioinnovations, which I was CEO until 2020 for 15 years, it moved its headquarters to Raleigh, to RTP, and has a little office here as well.
Well, I think I said it in my little intervention. We are here because we believe in collaboration. We believe in joining works together, and we believe in projects that everybody is contributing to one goal. And I think One Health is one of these purposes that is going to bring us together and finally get off of our silos.
So I would echo what everyone said. I think also training the future generation, right? And like, how do we push innovation and all work together? Because each of us is pushing it in different ways. We can help push each other. So it's really important that we all work together, push that innovation. And it's great being local here to be able to work with NC State as well. So.
Can you hear me, Deborah? This is Tim. I'll go ahead and answer from FAR's perspective as well, which is that we work with the industry very closely as part of our matching funding mechanism. On many of our projects, we're both addressing grand challenges through a One Health perspective or approach, but we're also working side by side with the industry. I actually want to give a shout out to Dr. Heather Fowler, who I saw in the audience. We just launched an RFA recently for projects related to air quality in and around swine production facilities. So there's a direct impact on human health. There's an animal component, and I'm sure there's probably perspectives that would relate more to the environment and the plants around those facilities as well that I'm not an expert on. But I think there's substantial interest from the industry around many of these topics, whether it's improving the nutritional quality of the crops that are grown, or in trying to address some of the environmental impacts of agriculture production. So a lot of our projects are One Health. So I'm happy to be here, excited to learn more. Back to you.
Hello, I'm Peter Burkett, and I'm also the director of the Animal Health and Nutrition Consortium. And that's a consortium of members. Paula, you're on the board of our industry advisory board. And you used to be. and that is a mission to fund research that basically floats everybody's boat related to animal health and which is both food animal and companion animals. And Tim Kurtz is also, has served and will serve some more on moderating the awards of our funding. My question is, we've got an infrastructure that we started about 2 years ago in that area. And this obviously seems to be a good fit with the One Health component. Our biggest challenge is membership, how to get more membership that leads to research. Does anybody have any good ideas of how you connect this with the academy? Maybe Sid could answer some of that, and anybody else.
Thank you, Dr. Puckett. I think the way to do this is to have discussion and see what we can do. I think, the momentum for this proposed One Health Academy has been really from the ground up. one of the strategies we used was just plant the seed in the senior administration. Hey, we want to try this, and what do you guys think about it? And yeah, just take a look at it and see what. Come back and talk to me in 6 months, and then we just went and started talking to people. I think that really helps. I think platform like this really helps. I don't know how many of you were aware before this meeting that NC State may potentially have like this Global One Health Academy before today, and I think that's what I'm trying to really do is to talk to more people and tell them more about it. I think talking really helps and bring more and more people. And then of course support from the administration is very important, and I really believe that when you start thinking about ideas kind of out of the box and something that organization has not done in the past, you need support from the administration and buy-in from them, at least in the initial idea. But I think talking really helps, and whatever traction this One Health Academy has had, I've been told you got to use the word proposed. The proposed One Health Academy is all because of getting momentum from the ground up and really saying, hey, look, we got this 100. I must have spoken to 150, 200 faculty just to talk to them. Gosh, the number of Zoom calls I've done, and I don't think I've had a single person tell me, I don't think so, this is a good idea. The maximum I've heard is like it's challenging because you're gonna have to convince everybody that's good. Everybody has been really supportive. I think that talking really helps, to really tell them, hey, this is good. And it has to be a two-way street. When you talk about One Health, it's amazing, right? It's a big umbrella, everybody fits in it. But I think sometimes that can be a challenge also because it tends to suck everything inside it. And then you get into this weird phase of, whoa, we spent 20 years doing this and all of a sudden this is One Health coming. So to be very aware of that, really, as Tim was talking, it's a systems thinking approach. The idea is that it has to be a two-way street, and really the established programs have to really benefit from it. And I think that's the academy model also. It's not like, this academy comes in and just starts taking all the credit. I don't think that's the idea. The idea is to really, take all the existing programs, bring them together so that they can go to the next level. So that would be my answer.
Very grateful to all of our external presenters. And now is when we shift gears. And you see the big smile on my face because this is an opportunity for us to show off some of our new faculty, some of our new projects, and how those relate to One Health. Please, as all of these people are speaking, remember, this is an emerging research showcase. And one of the things we're really looking for here is what are the external partners going to get out of this research and how will they impact the research through collaboration? And so with that preamble, it's a great pleasure to introduce Kerem Eroglu. Kerem is assistant professor in nutrigenomics in the Department of Molecular and Structural Biochemistry. The title of Kerem's presentation is Harnessing Carotenoid Metabolism in the Gut Microbiota and Its Implications for Host Inflammation. Kerem?
Well, thank you so much for this kind introduction and to all of you for being here this afternoon. It's my great pleasure to talk about our recent research. First of all, I would like to start with some background and significance. So carotenoids are naturally occurring pigments in plants and several other microorganisms such as algae and bacteria. And they are mainly absorbed in the small intestine. However, like other phytochemicals and nutrients, most of them are not being efficiently absorbed, ending up in colon, and that's why we are interested about their impacts on gut microbiota and the relationship between carotenoid metabolism and gut microbiome. So, and recently, last spring around this time, my collaborator and I look up the Human Microbiome Project. To our surprise, we were not expecting these nearly all participants, but to our pleasant surprise, we noticed almost all participants of Human Microbiome Project contained carotenoid modifying enzymes in their gut microbiota. Hence, we are very interested whether gut microbiome is also having some implications in relating to carotenoid metabolism too, because it has been shown in these last 20 years or so, it is implicated in metabolic health outcomes. However, there's a huge gap in the literature whether it has any implications regarding dietary carotenoids and gut microbiome. So our motivations and innovations are, we are posing these two big, beautiful biology questions. I really like this frame. Can carotenoids modulate gut microbiota? And the other question is, can microbially-derived carotenoids impact host inflammation? And here's the triad that we came up. So by answering these questions, we will connect the dots in linking these triad. So, and these are the list of innovations. For the interest of time, I will just briefly say the takeaway for the innovations are we will be building an interconnection between carotenoid metabolism and gut microbiota, and our study will be the first study to describe biochemical effects in the gut microbiota. So we started last year around this time again in a pilot study. We started collecting some preliminary data, and we used a diet-induced obese animal model where we feed them with carotenoids, and we found out that the gut microbiota was especially in respect of principal component analysis, we realized that they clustered separately after principal component analysis. And in panel B, what you see that clustering was significantly motivated, or it was motivated by the changes in the gut microbiome, especially with respect to some prebiotic features of carotenoids was noticed. My laser point is not there. It is. Okay, but at the bottom it's hard to see. Sorry for that, but you see some prebiotic features of carotenoids can be observed as we see significant changes across different dietary treatment arms. So once we noticed, there are some promising signs, but whether it has any effects on the host. So we ask ourselves whether we can demonstrate a clear connection between of microbial changes on the host organism. So to answer that question, we came up with a number of experiments. And again, for the sake of time, I will just talk about the changes, proteomic signature, and to the changes in proteome profiles. So what we have done, we have used these these workflows for using discovery proteomics. So what it is we isolated colon samples and we followed this workflow to determine whether there's any significant changes across dietary arms. And what we have noticed is what I have done, as you have seen in this functional enrichment analysis, once this workflow implemented, we have used web-based application to see which genes and proteins are enriched in our colon samples. And then we came across these proteins are involved in host inflammation. These proteins are also involved in oxidative stress. And most importantly, for the proof of concept, they were also related to carotenoid metabolism. So for future directions, we are interested. So far we established the link between gut microbiota and carotenoids. And now we are asking whether there are any carotenoid modifying enzymes. So to answer that question, we formulated a number of questions. Number one is whether can we find carotenoid active enzymes using several high throughput methods. And for that, you will see the 3 complementary screening methods. And then the next question is whether we can identify microbial carotenoids. And then for that, to answer that questions, these are the methods that we are using and we may be using in the near future, depending on the funding availability. And the last but not least, we are interested in whether can microbial carotenoids modulate host inflammatory pathways. And as you have seen in the previous slide, we have some answer and in respect of host inflammation. So we will be using our proof of concept discovery proteomics, high throughput proteomics to answer that last question. So one of the purpose of being invited here, not only for myself to gain additional perspective, also to build this network of partnerships so everyone will benefit. So in order to do that, I formulated with the help of Deborah, we formulated these 30-foot questions. And here they are. Question number 1, how can we advance scientific knowledge and activities that benefit society? And the obvious answer is to build partnership between academia and industry. The second question is, what are the potential impacts of these partnerships? This project will impact, I hope you have already seen the potential, will impact your product pipeline like commercialization, and also it will impact something like in terms of the benefit for the product development, and so for feedstock development, and for the food security, there are also implications for food security as well. So I will list 2 open-ended questions for your sake. So these are, what opportunities do you see in our research program for your company? And the other question is, what is the win for the company? So I hope I convince the potential in our research, and also most recently, we've been working with wonderful collaborators across the campus. Dr. Kochi is in the audience today. So if these NSF proposal will be funded, we will collect some samples from his group to not only use the mouse model, we will also collect samples across different disciplines around the campus, and we will see whether we can generalize carotenoid metabolism in diverse vertebrates and diverse organisms. So I'm very interested, very excited about that opportunity. So I'm working day in, day out just to move things forward. And I'm confident we will get it this time. So this is the resubmission. The resubmission deadline that we set up ourselves is June 10th. I will be delighted to get your letters of support for the industry. Industrial support is playing, it will play a key role, and I will be very grateful for that purpose. Okay, and that's it. And now, last but not least, these are really an extensive collaboration across different groups, multidisciplinary research that we've been conducting in different labs and facilities. And I will be taking questions in the next few minutes. Thank you so much for your attention.
So thank you, Karen, for giving us an example of a truly interdisciplinary project related to One Health. So Sid, this is number 1 on your list.
Sure.
This is very interesting, because I'm advising a company that has a Vietnamese red melon that has the highest carotenoids of any fruit or vegetable. So it's very interesting. So I was wondering, given that, does the source of the carotenoids make a difference? So you fed carrots to the mice. Do you think like something like a supplement, like preservation or tomatoes or some other source of it will make a difference in what's happening in the microbiome?
Well, that's an excellent question, because for this NSF proposal, we are suggesting to use a supplement. So that preliminary data that we collected for the USDA proposal that we submitted last spring. And we just found out it was funded. The study just started last month. And the reason that I'm really interested is, as you pointed out, the food metrics play a key role for absorption and digestion and bioaccessibility and bioavailability. I mean, I can talk many hours. But for the supplements, NSF is interested in whether we can, generalize our findings. And when they reviewed through in the first cycle, they really excited about these last future direction call. So that's the main reason that, that kept me going in the lab and, seek solutions. So we will be using supplements, mainly beta carotene supplements. Initially, I proposed both beta carotene and lycopene, but then they said, hey, you don't have any preliminary data for lycopene. You might as, and when I was reading the lines, between the lines, I noticed, you know what, they're right. Just drop that carotenoid species and concentrate on beta carotene. And the data is there. It's just tweaking. So that's what I've been doing in terms of, making sure that, we are on the same page and just justification purpose and other stuff. And last time also one other comment is they did not find the broader impact section very competitive. So they said, all in all, your proposal is fantastic, but you got to build component to reach society. So that's why I am being as much as practical as possible in these last months, and building partnership will hopefully suffice that need, meet that need.
So we'll be looking to you guys to answer his last two questions. It's not often that the presenter asks the questions, but thank you. Thanks,
Sure.
Kara.
Sure.
Lynn Walker is Assistant Professor of Applied Microbiology in the Prestige Department of Poultry Science. Lynn will be presenting on microbial safety and poultry quality. Thanks, Lynn.
Good afternoon, everyone. It's my great pleasure to be here, and thank you for this precious opportunity to present some of my projects or the research areas that might be interesting to you for some future collaborations. I'm an assistant professor in applied microbiology from the Department of Poultry Science. My research has been focusing on microbial safety. So as you can see from this pillar, there are three major areas that I'm experienced at: interventions, pathogen detection, predictive microbiology. And I'm focusing on both pre-harvest and post-harvest in poultry and poultry products. So my previous background, I had a lot of research experience in foodborne pathogens like Salmonella, E. coli. When we enter the poultry world, we're talking about Salmonella, Campylobacter, things like this. But since I started at NC State, a lot of the faculty members here, they are also heavily in the live production, which is the pre-harvest. So I started to extend my research in the microbial safety, also in the live birds. So not only the food safety, but also poultry health as well. And here, the next few slides, I'll just give you some examples of the projects that I had done or I'm working with the industry. Because I have a 60% appointment as extension specialist. So most of my research are very applied, and I work closely with the poultry industry or the allied industry. One of the topic is litter treatment. And just in case if you are not familiar with what a litter is for poultry, so it is in this picture, it is the bedding material mixed with the poultry feces, feed, water, feather, everything that you can imagine is split on this bedding material. So litter actually it plays an important role in the production and in food safety. And the industry has been actively looking for some innovative solutions to improve the litter quality. because it's directly associated with the productivity and food safety of the final poultry products. And for my specialty, I have been focusing on the safety part, the microbial safety part, which I teamed up with some other faculty members in our department. And we evaluated some different technologies, such as the antimicrobial chemicals, probiotics, and we just submitted a proposal to the U.S. Egg and Poultry on ozone technology to evaluate if the ozone application of ozone can be effective, can effectively reduce our targeted pathogens such as the bacterial, protozoan parasites, as well as viruses, which Dr. Kosey is one of the collaborators sitting here. I'm not a virologist. My main focus on the bacterial side and some of the protozoal parasites as well. As some of you know, and as some of the previous speaker has talked about food or feed, they play an important role in the food safety because it can change or modulate the microbiota in humans as well as in the birds. So feed additives. The whole industry has been actively looking for some, effective feed additives that can reduce foodborne pathogens as well as improve the gut health. So my main focus again is to evaluate, the feed additives to see if they can effectively reduce those pathogenic bacteria, such as the ones listed here, as well as the protozoan parasites. Those are some examples here as well. And actually my team, we just terminated a trial to evaluate a few products, and which is a commercial trial with a company. So this is just some examples how I'm working with the industry or the allied industry. So another area I'm working on is biofilm. So this is not only for poultry production, I would say maybe live production, livestock. It's probably a common problem because water, it can be a source of contamination, and biofilm, just as the picture showing here, it is a protection for the pathogenic bacteria. So if, let's say, Salmonella hides under this biofilm, then the antimicrobial treatment will become very hard or challenging to reduce those pathogens or to eliminate them. So my research was focused on, we investigated some innovative antimicrobial chemicals and to see if they are able to prevent the formation of the biofilm at the very beginning, or if the biofilm is already formed, if those chemicals are able to reduce the biomass of, for example, Salmonella in the biofilms. And so this is another thing, since, in the poultry industry, we as consumer, we are aware that the layer industry is moving from cage to cage-free system, which the whole layer industry is facing a lot of challenges in the housing systems, in their management practices. And so a lot of research has been going on, because once you move the bird out to the outdoor, which is the opposite, like what Pam just said, they want to move the plants indoor. So we're doing the opposite way. I don't know why, but there are a lot of microbial challenges associated because, as you can imagine, you have the wildlife, the birds poop on the farm, and those chickens, they are able to dig into the dirt to get access to all sorts of worms, parasites, insects, everything you can imagine. So, so the microbial safety is definitely being greatly challenged. And also, the stocking density is changed as well. So we are looking at the impact of stocking density, some kind of housing system, such as if we put some kind of flooring, which to protect the grass growing, those kind of things, if they will have a positive impact on the microbial safety to help to counter those challenges when the housing system is moved from cage to cage free. And again, due to the limit of time, I'm just giving you some examples that I have been doing with the industry. But again, I'm still developing my career and my portfolio. So since just examples, as my main focus is all listed in here. My whole passion is to improve the microbial safety of poultry and poultry products. So for me, I will be focusing on the intervention strategies to do some novel pathogen detections and predictive microbiology. That's just as important because I truly believe through the through understanding of those three areas or the successful application, those three areas, I truly believe a lot of food safety issues and animal health issues can be at least mitigated. So this is why I'm here, and I'm open for all the discussions, and thank you very much for this opportunity. Thank you.
Are there questions in the room? Oh, yeah. And
Are you working with anybody on insects as feed?
Insects, we have our other faculty member has been working with, I think, Wes on the insect part. Me personally haven't, but I'm working with some other faculty members, on the parasites part.
Do you think that insects as feed are going to reduce foodborne pathogens?
Oh, absolutely.
So?
Absolutely, because insects they are the biggest vectors. Is to transmit those pathogens, including parasites, bacteria, viruses, fungi. So, they are big vectors. So, the biosecurity part of the thing is how to control pests. Yeah.
there are no more. Lynn, thank you so much.
Thank you.
Our next presenter is David Rasmussen. David is assistant professor in the Department of Entomology and Plant Pathology. David's presentation is on do fitness trade-offs limit the emergence of generalist pathogens in agroecosystems?
Everyone. So I think, as we all know, pathogens continue to emerge both in humans and agroecosystems, especially in our plants and animals. And as most of us also have realized, these pathogens don't just materialize out of the thin air. They mostly come from other sort of plant and animals that are either part of our wildlife or native plant communities. And a lot of these pathogens sort of emerging into our agriculture hosts are themselves generalist pathogens that already have very wide ranges. And so all they're really doing is just expanding their host range to infect the things that we actually care about. And obviously these generalist pathogens are then very difficult to manage and control because we can't just control them in any one system. We would have to control them from a very sort of systematic perspective of controlling them in all their possible different hosts. So they present a huge potential threat to One Health for both plant and animal health. The thing that I've always found really interesting about generalist pathogens is that there's an incredible amount of ecological and evolutionary theory out there that says that generalists just shouldn't exist. The idea here is that if a pathogen is already adapted to one host and it starts adapting to another host, it has to pay some sort of fitness cost in terms of decreased fitness on its first host. And so it should be outcompeted by more specialist pathogens that are specifically adapted to that particular host. And this theory isn't without a good genetic basis. We know quite a lot about the genetics of host adaptation. And what we oftentimes see is that mutations that increase the fitness of a pathogen in one host decrease its fitness in another host, which, since geneticists need a fancy term for everything, we call antagonistic pleiotropy for some reason. But the opposite is also possible. It is rarer, but it's definitely possible for a mutation to increase the fitness of a pathogen in two different hosts at the same time, leading to what we call sort of fitness trade-ups rather than trade-offs, and leads to the opportunity of generalist pathogens to emerge without experiencing these fitness trade-offs. So the system that we use to explore how fitness trade-offs regulate the emergence of generalist pathogens is this plant virus, which is fascinating. It's called tomato spotted wilt virus. Does a great job of decimating our local solanaceous host here in North Carolina, like pepper and tomato, and tobacco, but infects other hosts like peanut as well. And that's within North Carolina, but globally, actually, TSWV is this incredible generalist and infects thousands of different species of plants and can replicate its insect vector. So I've gone on to call TSWV a super generalist because it can basically infect almost anything. And so the main focus of our research has been on understanding how TSWV adapts to new hosts and continues to expand its host range. And one of the ways that we can do that is by passaging the virus between different hosts. We can either passage the virus repeatedly on the same host to see how TSWV adapts to that host, or we can passage the virus between alternate hosts to see how the virus is able to adapt to multiple hosts simultaneously. And when we do these passaging experiments, one of the fun things we can do is we can deep sequence the viral population at every single time point, giving us a complete picture of all the genetic variation that's in the viral population at each time point. And this allows us to track the frequency of different mutations or different other genetic variants through time. So we can actually, in these time series, see how different mutations are changing in frequency over time. And we see mutations like up on the top here in purple, mutations that sort of increase in plants, but then decrease in thrips, the insect vector. And we see the opposite pattern as well, with fine mutations that do well in insects, but bad in plants. But by tracking the dynamics of these mutations through time, what we can do is we can use these growth rates of these different mutations in different hosts as a proxy for the fitness effects of these different mutations on the virus. And what we found was sort of completely shocked us, at least for TSWV. It seems like there's a whole bunch of different mutations, both single nucleotide mutations as well as amino acid mutations, that seem to sort of unconditionally increase fitness in different plant hosts. And you can say, well, maybe just a plant is a plant, and so the virus doesn't really care if it's in one of our two different experimental hosts. But the thing that surprised us even more then was that we also saw the same pattern between plants and the insect vector thrips, showing that there's a large number of mutations that seem to unconditionally improve fitness of the virus, both in plants and thrips. So our takeaway for TSWV was that one of the reasons why this virus might have evolved to be such an extraordinary generalist is because it's able to find all of these mutations that increase the virus's fitness in both hosts. And so when it evolves to adapt to a new host, it doesn't necessarily have to pay any fitness cost on previous hosts or alternative hosts. It can just sort of continue to increase its fitness over time on different hosts and continue to expand its host range. And so this made us completely reconsider how we think about these fitness trade-offs in regulating the emergence of generalist pathogens. I think before, like a lot of other infectious disease biologists, I always thought about most fitness trade-offs as being quite hard in terms of there being sort of these absolute biophysical constraints that prevent pathogens from performing well in multiple different backgrounds, almost like the kinds of resource allocation trade-offs that economists think about in terms of if we spend our time or money on one thing, we can't necessarily spend that time or money on another thing. There's necessarily an opportunity cost to sort of spending your time or money in one location. But these pathogens are obviously doing something different, or their trade-offs might be better thought of as being quite soft in terms of if they do experience continual selection pressures to adapt to multiple different environments, they find ways of adapting to these different environments, and they don't have to sort of pay any fitness cost when they're adapting to a new environment. So our takeaway was that a lot of what we hoped were maybe these hard trade-offs limiting the emergence of generalist pathogens might actually turn out to be quite soft in terms of if the pathogens are actually experiencing selection pressures to expand their host range, they're going to find ways, or they're going to find mutations that allow them to simultaneously adapt to different environments. But I think, so I'm obviously way over here on the basic side of science, and I realize many of you are way over here on the applied science front. But I think this opens up a new sort of really interesting research challenge, in that a lot of sort of the trade-offs that we sort of expect to limit the emergence of new pathogens or prevent the spread of antibiotics or prevent breakthrough pathogens from breaking down our resistance strategies, I think are actually forms of what I've called soft trade-offs that can easily be overcome by these pathogens. So I think a new research challenge or objective for us should be trying to find the hard trade-offs that are very hard for these pathogens to overcome. Thank you.
Okay, that was a lot. That was a mouthful.
Sorry.
No, it's good. It's good. Of course you have a question. All right, you first and then Sid.
So global climate change, are you expecting to see an emergence of more generalists as weather changes and becomes hotter?
Ooh, that's a good question. I actually don't know. I do know of lots of examples where it seems to be getting the weather or warmer weather seems to facilitate expansions of host range. I guess most sort of notoriously recently has been the expansion of different fungal pathogens into warm-blooded mammals. And some have argued that that sort of pre-adaptation to warmer environments has sort of facilitated that spread of fungal pathogens into humans and other warm-blooded animals. But across the board, I have to say, I just not sure. It's a great question.
And do you, is anybody going to be looking at the symbionts in the gut of the thrips that might favor or work together with the spotted whale virus?
Yes, actually, my colleagues right in the entomology and plant pathology department, Anna Whitfield and Dorit Rodenberg, are interested in that very exact question and are interested in the endosymbionts that regulate viral growth in the gut.
Hey, David, great presentation. So coming from the bacterial world, we see the impact of the fitness in terms of resistant pathogens, right? So a classic example is, you can find multiple serotypes of salmonella at different hosts. So typhimurium, for example, you will find in thousands of different hosts. When you look at another serotype, Enteroidetes, it's only found in eggs, most predominantly. So something is in terms of host adaptability. But when, the normal thought process with resistance world is, these plasmids are heavy, they're heavy fitness costs. So, if you don't use antibiotics, pathogens will eventually get rid of these plasmids and return to a susceptible state, which is good for the whole world. But that is not really happening. We find a lot of resistance in, in sustainable farming systems, for example, that don't use any antibiotics or any disinfectants. And so I'm just curious, is the bacterial world different than the virus world in terms of fitness cost and how these pathogens are adapting, even when those selection pressures are not there?
Well, I'm glad you brought up the example of AMR in bacteria, because I think this is a classic example where a lot of people interested in controlling the spread of antibiotic resistance have just sort of assumed that there's this absolute trade-off between being resistant or susceptible to a particular drug. And it actually turns out, and we know this now, that it's very easy for bacteria to sort of offset the cost of resistance. They can acquire additional mutations or additional adaptations that allow them to offset that initial cost of resistance. I was just recently reading about, plasmid-acquired resistance. As you said, it's often believed that these plasmids are sort of heavy and might slow down the growth rate of these bacteria. But a lot of researchers looking at resistance in E. coli and Salmonella have begun to found that there's also chromosomal adaptations that occur within the E. coli genome that allow them to reduce the cost or offset the cost of carrying these heavy plasmids. And so I don't think we should really think about these trade-offs in a sort of, absolute trade-off framework. We should really think about these trade-offs in a continuum of like, how hard is it going to be for a given bacterium or given virus to overcome these trade-offs?
Pathogens are way more smarter than we are.
Yeah.
David, I'm thinking about whether you could use these results with TSWV to think about the opposite. Some viruses are they're specialists and they don't have a whole lot of wide host range like TSWV, and whether you would see, what what would you predict there? So maybe comparing something that's kind of a narrow host range virus, and then also whether you can pick out of those genes that you sequence from the virus TSWV genome, what are the ones that are really promoting fitness in the genome, you know, or you know, are there like, and I know Anna's looking at the virus from a virology and the different viruses from taxonomy standpoint. Are closely related viruses to TSWV? Are they going to have these same traits? You know, could you get into like, I'm asking you several different questions here, but
Yeah. Well, so to go, I guess, back to your first question about the difference between specialists and generalists, I often think that the difference often lies in sort of, or is contingent upon the history of the pathogen. A great recent example of this, I think, would be the coronaviruses, where you would think of coronaviruses as necessarily having to be specialists because they have a glycoprotein that allows them to bind and enter their animal host cells. And there has to be a very sort of specific lock and key mechanism for those glycoproteins to allow for cellular entry. So we might expect them to be specialists, but we again and again see coronaviruses in bats and other mammals that seem to be rapidly transmitted a bunch between different hosts that seem to have evolved more of a generalist strategy and have found glycoproteins that can maybe overcome some of these fitness trade-offs between different hosts, and now allow for that virus to rather efficiently infect a bunch of different species of bats or maybe even other mammals. So I think maybe what we see as specialists might be sort of the outcome of long-term sort of selection pressures to do a particular thing in a particular environment. But we should not mistake that with a general lack of ability to become a generalist if the right selection pressures are there. And sorry, I forgot your second question. Yeah. So a very interesting thing about TSWV is it's part of this larger family of hospiviruses, plant-infecting viruses, and some of its family relatives are actually specialists and only infect a very small number of plants. So in that case, I think I would argue again that that's probably likely a byproduct of the different history of those different pathogens, either having to move between multiple different hosts, possibly because they also have a generalist vector that's feeding on many different plant hosts. Yeah. But I think also, you know, like I was saying, there's different, you know, processes and different constraints and, you know, how well a virus will do in different hosts. Oftentimes when we think of viruses, we just think about viral fitness as being all about replication. How well can you replicate in each host? And it might be very easy for a given virus to find strategies for replicating very well in different hosts, but it might be hard for the same virus to find strategies that work well to give that virus for other aspects that are necessary in its life cycle to have high fitness. For example, it might be hard for a plant virus to find strategies that allow it to move efficiently in the vasculature of different plants, or it might be hard for other viruses to find generalized strategies that allow them to escape from the innate immunity of multiple different hosts. So I think that's sort of an interesting reason in and of itself to try and think about, you know, what's likely to constitute these soft trade-offs that viruses can easily overcome, and what's likely to represent a hard trade-off that would be much harder for the virus to sort of evolve over or escape. Thanks for the extra time.
Skylar Hopkins was in the field today. And so she has sent her a recording of her presentation by Zoom. Or she's going to do it live, whichever. Skylar, welcome.
Yeah, I'll do it live. Thank you guys so much for having me today. It's been really great to hear about your ideas for the future of One Health at NC State. So if they give me just 1 second, I'll share those slides. All right, we should be good to go now. So I'm an assistant professor in the Department of Applied Ecology. I'm also in the Global Change and Human Wellbeing Cluster, and I'm an affiliate of the Southeast Climate Adaptation Science Center. So I wear several hats here at NC State. And one of those hats is that I lead the Sustainable Health Ecology Lab, where we research infectious diseases or parasites, and all of our work has applications to conservation or human health. One thing we research are win-win solutions. So these are interventions that simultaneously reduce human infectious disease burdens and advance some kind of conservation goal. And this is probably best illustrated with an example. So let's start with one from our research. When people can't afford healthcare, they sometimes cannot act in ways that are sustainable in the long term because their immediate needs are so dire. And so the horizontal bars on this map are showing you that there's a lot of overlap between regions with especially low healthcare access, which we would like to improve, and regions with especially important forest resources, which we would like to conserve. In Indonesia in particular, there's been a moratorium on new logging concessions since 2001, but deforestation has continued due to illegal logging, which is about 60% of the logging pressure there. And this is true even in national parks. So here I'm showing you the change in forest cover since 2000 for those national parks. People living near national parks often have subsistence livelihoods without cash income, and reported that they often cut down trees because they needed fast cash to pay for healthcare. So an NGO called ASRI built a healthcare clinic that provided health discounts and also allowed people to pay with non-cash items. And the clinic was heavily used by villages that collaborated with the NGO and also villages from relatively far away. And when we analyzed deforestation rates in the nearby national park and compared that to other national parks in Borneo, we found that the national park with the clinic had less deforestation on average after the clinic had been built than those other sort of control national parks. So this is a win-win where we are providing healthcare access, reducing various metrics of human disease, and then also reducing deforestation. As a short aside regarding industry applications, quantifying deforestation and forest recovery and carbon storage are huge areas of research and application right now. And these are methods that we create and use in our research. The ASRI example is just one example of a win-win. And it turns out that these come in all kinds of flavors, like vaccinating dogs to prevent rabies transmission to dogs, wildlife, and people, or creating waste management systems that prevent pathogens from entering water sources shared by people and wildlife. And I led a working group effort that identified 46 potential solutions and reviewed evidence that they were safe, feasible, and effective. Some of the 46 potential solutions were supported by diverse, high-quality evidence already, but many either had limited evidence, inconsistent evidence, or evidence that wasn't particularly applicable to the context relevant to understanding if the intervention worked or not. And at first, the scientists among us found this a little concerning, like maybe people have been overselling this idea of win-wins with solutions that are more of an idea and not particularly well supported. But the practitioners in our group pointed out that potential solutions that are expected to be safe and feasible are the ones that might be the most exciting, low-hanging fruit for future research and adaptive implementation. So summaries of each potential solution will be published in an online website soon when the paper comes out in Lancet Planetary Health. So if you're interested in implementing these interventions or evaluating their impacts, you can look through these examples to see if any are relevant to the work that you do. And I want to point out that this huge synthesis effort would not have been possible without our large team of collaborators. So there were 28 interdisciplinary researchers and practitioners who worked to identify and evaluate the 46 solutions. This included, researchers, people in vet med, people in agriculture, and also our efforts to understand how health influences deforestation wouldn't have been possible without the NGOs who designed and implemented those massive interventions in Borneo. And so these collaborations are very important to us, and they're something that we can leverage in the future as we try to do these One Health interventions. So with that, I'm going to thank you all for listening, and I will be happy to take any questions.
Thanks, Skylar. Any questions in the room or online? So while Anthony is checking, Skylar, this is, oh, you can't see it.
That's okay. I can hear you.
Well, and that's the most important thing, but I'll give you something to look at now. So I'll admit, I never really thought about the continuity between diversity, conservation, and One Health. And so that to me is a fairly unique viewpoint. What I'm having a little trouble with, and again, this is my role, right? My role is industry collaborations. What I'm having a little trouble with is, where do you see industry interacting with you in this problem, in this challenge?
Yeah, so I think it depends a little bit on the solution. And so one thing I think that's important to note is that there isn't just one solution for our planet, right? We have lots of problems that are interconnected, and we need lots of different solutions. So for example, we do have one solution that's about better biosecurity for poultry production. So we know that, for example, H1N1 is going to be a bigger risk if we have people from low-income backgrounds who don't have great access to healthcare or can't take time off from work. And they're working in environments that have poor biosecurity. That is just asking for a disease emergence event, right? So protecting those particularly vulnerable populations means that we're not going to get emergence into human populations. And also we might be benefiting wild bird populations, which are also, negatively affected when people think that those wild birds are the source of these infections. And so that's like a particular industry example, but I think all of these solutions have areas where we could branch out in an industry direction if people haven't already done that.
That's great. Thank you. Are there other questions in the room? I don't see any. Oh, hang on. One comment. No. I have to use this.
USAID's put a lot of money into cook stoves for smallholder farmers in places like Indonesia and Africa, because the tree removal is not just used for money, but for food, for cooking food. So innovations in coming up with better sustainable methods of preparing food so you don't have to remove the trees, because when the trees are removed, the bats and birds that might carry pathogens migrate somewhere else. And that's how you can get virus spillovers or other pathogen spillovers to different hosts, because the tree hosts are removed. So, it's all very interlinked in One Health. And
that is one of our solutions as well. So cleaner cook stoves can, like you said, reduce those biomass requirements. And also the wood burning stoves are quite bad for human health, right? So the smoke causes chronic health issues like asthma, but it can also predispose people for infectious diseases that result from having poor respiratory health. So yeah, that's a great example.
Thank you, Skylar. Our final presenter tonight, this afternoon, is Churchill Wang. Churchill is an assistant professor in the Department of Animal Science, and his presentation is on animal biochemistry and physiology.
I promise you I won't be holding you too long. So my name is Churchill Wang, and I'm an assistant professor from Animal Science Department. And today I'm going to share you the major direction of my research program. I will start with several historical drawings related to the reproductive biology. So looking at the two pictures on the left, you will see this is the drawing about the Greek god Zeus that releasing a egg-shaped like the container or boxes for the creatures all created. And he's spelled exo ovo omnia, which literally means all things come from the egg. This was first coined phrase by William Harvey, which is the 16th century anatomist who is famous for his discovery of the circulation. He's also probably the first physician to Charles I. And this statement represents a major theory during that time that all the things from the egg and during all the reproductive cycle of the animals be involved with the egg function, as opposed to the spermists at that time thinking about the remnantly state that the male seed was the source of an organism, which shows you can see the sperm. They actually, people thinking there's a baby or fetus inside the sperm and planting itself into the soil provided by the menstrual blood. Well, as our knowledge progresses nowadays, everybody knows that a successful pregnancy requires viable eggs and also a sperm. And on top of that, you also need the soil, which is not the menstrual blood, it's the uterus. So that's my lab focusing on the uterine biology and the pregnancy. Because with the modern technology, such as assisted reproductive technology, you don't even need a viable sperm or viable egg. You can create an embryo there. However, the era of artificial uterus has not come, not anytime soon. So in my lab, my research program focuses on two major directions. The first is the synchronous uterine and concepts development in the ungulates, including the pigs, the ruminants, such as the sheep and the cow. Another direction is to study the age-related uterine adaptation to pregnancy. So the picture shows here is actually the progression of sheep conceptus actually throughout the window of receptivity. So different from mouse or human embryo, all those conceptus from ungulates, including sheep, pigs, and other ruminants, their conceptus means actually the embryo and the future placenta together. So they will actually undergo a transition from the spherical to tubular to filamentous forms. This is very unique for livestock species, such as the pig, sheep, and ruminants. And during this stage, they have to correlate it with uterine environment, or say that they will produce a lot of nutrients, regulating factors. However, this is understudied area. And just because you feed animal or what we eat, the nutrient what we consume, doesn't mean they will translate directly into the uterus, supporting the embryo development. So why pigs? So pigs are the leader-bearing species that exhibit a high incidence of the embryo death, natural occurring IUGR, intra-uterine growth restriction, and they also have a high significant number of stillborn piglets. Actually, in the United States, from 1970 to 2000, the average leader size is actually increased from 7.3 to about 10. And during the last 2 decades, they actually staggering there. Why? Because the large litter size nowadays in the commercial breeding herds often increase the birth of we call the round piglets. In other words, it's intra-uterine growth restricted piglets. In human side, we call the fetal growth restriction. And those are actually will cause a lower rate of survival of the neonatal piglets. So just because you have this number of piglets born doesn't mean they will survive through the weaning period. What's the solution? So in our lab, we'll focus on the two major subdivisions for this part. The first one is the mechanism by which the uterine status and the conceptus development synchronize. leading to the successful establishment of the pregnancy. So this part is currently funded by USDA. And the second part, we want to know what's the functional or regulatory roles of those uterine derived or the conceptus derived factors that will govern this process. This actually were fortunately funded by the seed grant from the from NC State. And the third part, as a nutritionist by training, we also want to know what's the solution, what's the nutrient by diet to actually can improve this process by induce more of the endogenous factors, facilitate this process. We actually did several studies actually focusing on the amino acid and also the fatty acid. So we have some preliminary data. Fortunately, this part of the project is currently funded by Ag Foundation, and I could see the potential industrial collaboration opportunity. So now I will switch the gear to the other side, the human health, as part of the One Health program. So we know that the advanced maternal age usually means the women who has the age more than 30 years old, especially they have the first or subsequent pregnancy, is considered a major risk factor for the birth defect. The women who has advanced maternal age, their pregnancy will suffer from the miscarriage, late fetal or prenatal death, stillbirth, also IUGR. On the women's side, they will actually suffer from the preeclampsia and other medical complications such as gestational diabetes, and the maternal mortality rate is pretty high once they reach an advanced rate. And this is not only during the pregnancy, sometimes it's after pregnancy. And well, what's worse is nowadays, women worldwide tend to delay their first motherhood because of a variety of reasons, such as the higher educational attainment, effective contraception method developed, increase the career options, changes in value and family structures, so many reasons. On top of that, our environment is not kind to us. So the lifestyle factors such as tobacco smoke or alcohol usage, as well as environmental stressors, heavy metals, environmental toxins, also make this worse to accelerate the reproductive aging. So understanding the precise mechanism by which the female reproductive organs age is actually the prerequisite for ultimately develop the counteracting measures. So speaking of reproductive aging, most of you probably think about, oh, it's because in terms of female side, it's about low quality of the oocyte or the abnormal function of the ovaries. It is true somehow. So we found that the occurrence of the embryo aneuploidy in the women over 35 years old partially explain these poor pregnancy outcomes. However, we also hypothesized that the uterine environment plays such an important role in supporting the pregnancy. And this has been supported by us with our collaborator. We found that compared with the younger pregnancy in a mouse during the natural mating, they will produce a normal developed conceptus, normal developed embryos. However, in the aged mice, which is usually beyond 45 weeks old, they actually develop a variety of abnormality of the fetal development. However, once we did embryo transfer, so we transferred this aged embryo to the younger surrogate, they actually get rescued. So this actually means not only the ovarian function or oocyte quality is important, probably more importantly, the uterus, we call it the soil, right, is more important to support the aged embryo to develop properly. However, what's the mechanism underlying that is still unknown. Here in my lab, we recently developed a transgenic mouse model that actually recapitulates, if not fully, but partially recapitulating this fast aging phenotype. So this data just shows you that the red color stands for the positive staining for this age-related fibrio type 1, type 3 collagens, showing that fast aging. So you can see on the left, that's the sorry, that's not the genetic, that's the control actually. That's the control at the 6 to 8 weeks old. In the middle is actually our genetic mutation. So you can see that's actually start to show in this red color, even at very early stage, 6 to 8 weeks old. And our positive control is the wild type mice, who is like 46 or 54 weeks old. So you can see the trend. And with this model, we try to study the mechanism by which the uterus ages in this mouse model in terms of the genetic mutation, epigenetic disruption, such as DNA methylation and the histone modification. We also want to know what's the environmental stressor to cause this, so we can test our hypothesis using this model. And this one is currently funded by our the Center of the Human Health and Environment, and also we have NIH funding grants pending. So simultaneously, we want to develop this counteracting measures. So we were seeing that, how about we develop a nutrient intervention through the therapeutic diet? We can test that in our model. And secondly, we want to actually develop this customized hormonal therapy for the IVF patients, because a lot of time IVF patients suffered is not because of the quality of the embryo, it's actually the hostile uterus. So with the assisted reproductive technology, you can get the healthy embryo, but you cannot get a very healthy uterus once the woman under like more than 35 years old. So by using this, we are in the process of developing this patient-based uterine organoid culture. Actually, we can customize what's the hormonal pattern or what's the diet specifically fits this patient. And then we can actually transfer this knowledge back to the clinic treatment for the patient. So this one, I could see a potential opportunity to team up with the industrial partners. Well, by that, I want to thank my lab members and collaborators. Without their support, those sort of things can never happen. And I will open the stage for any questions. Thank you.
It's late. You're all tired. Are there any questions? You knocked them out. Thank you, Churchill.
Thank you.
Any idea what therapeutic measure, any idea what therapeutic measures, nutritional measures might help?
Well, we are actually studying amino acid with lipids right now. Yeah, so, and we were testing that using the both in vitro and in vivo model to see, we actually knock out a specific gene that's sensitive to those nutrients.
And it worked in mice?
Yes.
It's about maybe 15 years ago, we had done some research on in ovo feeding. So we have the same problem with chickens, that we have poor hatchability, and it's related to older hens and things like that. But what was really remarkable, if we put certain nutrients in ovo into the amnion, that we could rescue the embryo and then they could actually hatch and have much better performance. And it actually has everything, effects of programming their epigenetic response and all kinds of interesting things. And it depends on the formula that you give, what kind of response. Do you think a technology like that, if you literally injected nutrients into the amnion, could kind of study the effects so that you can go back and figure out, okay, what do we have to feed the sow or the chick? So that's what we're doing in research, for doing that kind of research and then going back and saying, what do we have to do to the laying hen to correct this?
Excellent question. Actually, that's part of our plans to actually inject it, started in the mouse. We can actually do the injection into the amniotic sac and to actually see the effects. But eventually we want to do, not using this invasive effect, we want to see what's the diet or what's the combination of diet or with hormone treatment actually increase the efficiency for transport of the nutrients. And that's absolutely right. And it's feasible to do. Yes. Don't know if I answered your questions.
Well, thank you so
Okay,
much.
thank you.
Thank you to all of our presenters. This was lots of fun, and I'm very grateful. Let's thank our presenters and all of them, because we had, what did you call it, Anthony, a cast of thousands? So thanks once again to all of our presenters for today. Quick reminder, our aim for these events is to get external stakeholder eyeballs on these projects. So please share. Please let us know if you're an external collaborator or even an internal collaborator, because sometimes we make really interesting connections inside the university that we wouldn't have made otherwise. Please let us know how to follow up with you. We're going to close the Zoom. Thank you to those of you who joined virtually, and in theory, there is wine and snacks outside. So please stick around.